Good morning to all. The last class we were studying about the trends in the periodic table. That means how the properties of the elements varies among periods and groups. We have already studied the two things, that is the valency. In a group, the valency remains the same from top to bottom, and in a period the valency increases one by one up to 4, then decreases to 0. Second thing we studied is the size of the atom, the atomic radii. The atomic radii increases in a group from top to bottom because the number of shells increases, and in a period left to right the atomic radii decreases because in a period the neutral charge increases, therefore it pulls electrons to the center. So the size of the atom decreases in a period. Therefore, the next thing we have already seen, which is the biggest atom and which is the smallest atom. The third thing we are going to study is how the metallic character and non-metallic character changes among periods and groups. Let us see the periodic table. I said to you that in a periodic table, the left side metals, right side non-metals. In between metals and non-metals, there is metalloids. Then, how the metallic character varies from top to bottom. Similarly, how the metallic character varies in a period. What is the metallic character? What is the metallic character? What is the chemical? We have learned the physical properties of the metals, non-metals and the metalloids. How we can identify a metal and a non-metal in a chemical reaction? How we can identify a metal and a non-metal by how we take part in a chemical reaction? The most important thing you always remember is that a metal always loses electrons in a chemical reaction. The metal always loses electron in a chemical reaction. That property is known as electropositive nature, electropositivity. That means electrons have negative charge. Therefore, an atom loses an electron, it gains a positive charge. That means metals are electropositive elements. Why metals are called electropositive elements? When take part in a chemical reaction, metal always gives electrons. That is the identical property of metal. At the same time, on the other hand, non-metals always receives electrons in a chemical reaction. Non-metals always receives electrons. That character is known as electronegative character. Electronegativity. The electronegativity means the tendency of an atom to attract electron towards it. The electronegativity is the characteristic of non-metals. Similarly, the electropositivity is the characteristic property of metals. Electropositivity, metals character. Electronegativity, non-metals character. Electropositivity means tendency to donate electron, tendency to give electron. Electronegativity means tendency to attract electrons. Then we can, in this episode, we are going to study how these properties varies among periods and groups. We can first look upon the first group. There is the clear-cut difference between metals and non-metals up to this 6 movement. Up to this, these are the metalloids. On the left side of the metalloid, there was metals, and the right side, there are non-metals. Then we can see in a group, the size of the atom increases from top to bottom. In a group, the size of the atom increases from top to bottom. Then there arises a question: which has more tendency to lose electron, smallest atom or biggest atom? Can you find the answer? Do you understand what's the question? For example, in the case of lithium, it has only two shells and at the same time francium. These are all metals. Lithium and francium are metals. Which is more metallic, either lithium or francium? In the periodic table or the universe, no two elements have identical reactivity in every. There is one is slightly reactive, more reactive, or one is slightly less reactive. My question is, either lithium or francium, which is more reactive? In the case of metal, how I can classify a metal which is more reactive or less reactive? What is metal's character? Metal's character is to donate electrons, to give electrons to other elements. Which metal which gives easily electrons is more metallic, more reactive? You understand? Which metal which gives electrons easily is more metallic or more reactive? Which metal which gives not at easily or comparing to other, less tendency to lose electron is less reactive. For example, you can see lithium and sodium. Take lithium and sodium. Lithium has only two shells. Sodium has three shells. Which donates electron, which gives electron more easily? In the case of atomic radii, we learned that electrons are attracted towards the center. In the case of smallest atoms, electrons are close to the nucleus. In the case of biggest atoms, electrons are far away from the nucleus. Small atoms, that is small atomic radii, small atoms, electrons are closer to the nucleus. Biggest atoms, electrons are far away from the nucleus. Which has more tendency to lose electrons? There is no doubt, biggest atom. Biggest atoms, electrons are far away from the nucleus. So the attraction of the nucleus to the valence electron is very less. So it can very easily donate electrons. But in the case of smallest atoms, electrons are closer to the nucleus, near to the nucleus. So it is not an easy to pick an electron or to donate an electron from the nucleus because electrons are closer to the nucleus. The attraction between the nucleus and the electron is very high, so it has less tendency to lose electrons. Then we can came to the answer: which element has the which metal is more reactive, small atom or biggest atom? There is no doubt. Metallic character is to give electron or donate electron. Biggest atoms have high tendency to give electron, so it is more reactive. In the case of smallest atoms, the electrons are closer to the nucleus, therefore the tendency to lose electron is very less, so it has the least reactive. Then we can take the case of each group. In the case of lithium, 2 shells, and the case of sodium, 3 shells. In the case of lithium, it has only 2 shells. Then the electrons are closer to the nucleus. At the same time, sodium, it has 3 shells. So the outermost electron is far away from the nucleus. Comparing to lithium, it has more distance from the nucleus. So sodium, comparing to lithium and sodium has the greater tendency to lose electrons. So it is more reactive metal than lithium. Comparing lithium and potassium, the same case also. Lithium has only 2 shells, potassium has 4 shells. Which lose electrons easily? Potassium. Why? In the case of potassium, the valence electrons are far away from the nucleus. So the attraction of the nucleus to the outermost shell is very less. So the electrons easily lose. So in the case of first group elements, which is the most reactive metal, you always know hydrogen is not a metal. When reactions take place, it has both the properties. It shows both the properties of metals and non-metals. So it is not difficult. In the case of scientists, it is not difficult to find a position in the periodic table of hydrogen. So at last, its properties most resembles, though it is a non-metal, its properties most resembles to the alkali metals. So at last, it placed among the top of the first two elements, though it is shown in a special color. So the first group, which is the most reactive metal, francium. Why? In the case of francium, it is the biggest atom, and the outermost electron is far away from the nucleus, and it is easy to give electrons to take part in chemical reactions. So in the case of second group, which is the more reactive metal, beryllium or radon, beryllium or radium. Beryllium has only 2 shells. The outermost electron is very much closer to the nucleus. Only 2 shells. At the same time, radium 7 shells. 7 shells. So the outermost electron is far away from the nucleus. So radium gives electrons very easily, so it is more reactive. So in the case of metals, the reactivity increases from top to bottom. In the case of metals, reactivity increases from the top to bottom in a group. You always remember the proper reactivity of the metals depends upon its tendency to lose electrons. The reactivity of the metal depends upon its tendency to give electrons. If it is give electrons more easily, it is more reactive. If a metal gives electrons, the tendency to give electrons is very less, it is least reactive. So that in the case of metals, the reactivity directly related to the size of the atom. The reactivity of the metal directly related to the depends upon size of the atom. If the size of the atom is small, it is less reactive. If the size of the atom is big, it is more reactive. The reason is that if the size is small, the electron is closer to the nucleus and the tendency to lose electron is very less. And at the same time, the size of the atom is big. The electron is far away from the nucleus and it is easy to give electrons. So the next thing you have learned is how the metallic character. Metallic character means lose electron. How the metallic character changes in a group. In a group, metallic character increases from top to bottom. In a group, the metallic character increases from top to bottom in a group. The reason is, what is the reason? The size of the atom increases. This is also known as what? Electropositivity. In the case of metals, electropositivity increases from top to bottom. Metallic character is electropositivity. That means when an atom lose electron, it gains a positive charge, or the tendency to give electron is known as electropositivity. So we came to a conclusion: the two things In a group, from top to bottom, metallic character increases because the size of the atom increases. Electropositivity increases from top to bottom. Then we can note down the non how it changes in a period. You take the second period. I said to that the metallic character means tendency to lose electrons, tendency to give electrons. We have learned that in a period from left to right, how the size of the atom varies. The second period, all the elements have two shells. The period number denotes number of shells. The second period, they have two shells, K and L. Then how the size changes? The second period, the size decreases from left to right. Why? Though they have only two shells, the nuclear charge increases from left to right. The nuclear charge increases one by one. That is lithium 3 positive, beryllium 4 positive, boron 5 positive, carbon 6 positive, nitrogen 7 positive, oxygen 8 positive, fluorine 9 positive. The nuclear charge increases from left to right. Likewise, gradually it attracts electrons more towards the center. So the size of the atom decreases. Size of the atom decreases means metallic character decreases. That means metallic character, what is metallic character? The tendency to lose electrons. The tendency to lose electrons. It depends upon the size of the atom. How? Size decreases means the outermost electrons made closer to the nucleus. So the tendency to lose electron is very less. At the same time, if the size is big, the outermost electron is far away from the nucleus, so it can easily give electron. Then we can take conclusion in a period from left to right, metallic character decreases. Metallic character decreases. Why? Size decreases. Therefore, the tendency to lose electron is very less. So, where we can see the more reactive metals on the left side. More reactive metals on the left side. On the left side, top or bottom. While you are always studying about metals, you will always remember that metals means metallic character. What's metallic character? Tendency to lose electron. The tendency to lose electrons always related to the size of the atom. If the big size, the tendency to lose electron is very great. If the small size, the tendency to lose electron is very less. So, we came to the conclusion that which is the biggest atom among the elements? Francium. You can note down the period table. The biggest atom is the francium. It is the most reactive metal. Francium is the most reactive metal. Why it is the biggest atom among the all the elements, so it has the greater tendency to use electrons. It has the more electropositive element, which is the more metallic character is same as electropositivity. It has the most electropositive element. Of course, electropositive elements, how it is easily lower electron, it is more electropositive. Then we can come to the another classification, the non-metals, where we can see the non-metals in the periodic table on the right side. On the right side, we can see the non-metals. Right side means the right hand is are also zero group elements. They does not take part in chemical reaction because they have a completed octet, filled shells. Except this 0 group elements or 18th group elements, we can do the next 17th group elements. What are the 17th group elements? Fluorine, chlorine, bromine, iodine, astatine. These are the 17th group elements. They are also known as halogen family because they have the same properties. They have the same properties by number of, they have the same valence electrons. They have 7 valence electrons. The properties of an element depends upon the number of valence electrons. Valence electrons means the number of electrons on the outermost. We can see fluorine, chlorine, bromine, iodine, astatine, oxygen, sulfur, selenium, tellurium, polonium are metals. These elements are non-metals. These elements are non-metals. What is the non-metallic character? Non-metals always accept electrons or receives electrons. The property or the reactivity of the non-metals depends upon how easily it attains an electron, it gains an electron. This is also known as electronegativity. Electronegative character. Why we call it electronegativity or electronegative character? We learned that what are the fundamental particles in an atom? The fundamental particles in an atom are proton, electron and neutron. Protons having positive charge, electron having negative charge and neutrons no charge. Electrons have negative charge. When an electron receives an atom, it also gets an additional negative charge. So it is known as electronegativity. Electronegativity is the characteristic property of non-metal. Then we can go to study how this non-metallic character or electronegativity changes in a group and a period. It is on the reverse of electropositivity. Electronegativity means the tendency to attract electron. Then please you think which atom have the more tendency to attract electrons? Small atoms or big atoms? Which atoms have the more tendency to attract electrons? Which particle or which part of the atom attract electrons? You know, electrons are always revolving around the nucleus. It is never thrown out from the surroundings of the nucleus because electrons are always attracted by the nucleus. The electrons are always pulled towards the center due to the positive or nuclear charge of the nucleus. So my question is, which atoms have the greater tendency to attract electrons? Small atoms or smaller atoms or bigger atoms? In the case of smaller atoms, electrons are closer to the nucleus. So it has the greater tendency to. At the same time, in the case of biggest atoms, the electrons are far away. The outermost shell is far away from the nucleus. For example, in the case of astatine, it has 6 shells. The outermost electron is 6 shells far away from the nucleus. So the attraction of the nucleus to the outermost shell is very less. And when an atom receives an electron, it must enter the outermost shell. It can never enter the innermost shell. So in the case of non-metals, the electronegativity depends upon the size of the atom. That means smaller the size, it has the greater electronegativity. In the case of this fluorine, it has only 2 shells. At the same time, chlorine, 3 shells, which has the greater electronegativity, greater tendency to attract electron. Fluorine, only 2 shells, can attract electrons more easily towards the center. Otherwise, chlorine, electrons are 3 shells far away. So it has less tendency. So fluorine is the more electronegative element. Comparing to fluorine and iodine, which is more reactive. In the case of non-metals, The reactivity depends upon the tendency to attract electrons towards it. So in the case of smaller atom is fluorine, so it is more reactive. Iodine is less reactive. Fluorine is more reactive. Chlorine is lesser than fluorine. Bromine is lesser than fluorine and chlorine. Iodine is lesser than the above three, and astatine is the least reactive in the 17th group. Similarly, the 16th group, the more reactive element is oxygen. The reactivity decreases from top to bottom. This also. Then you compare this electropositivity and electronegativity. Electropositivity is the metallic character and electronegativity is the non-metallic character. Electropositivity is the tendency to lose electron. Electronegativity is the tendency to attract electron. Electropositivity means tendency to lose electron. It increases when the size increases. And the case electronegativity is the tendency to gain electron, to attract electron. It decreases when the size increases. So we can compare what are the things we learned today. The heading is trends in the periodic table. Trends in the periodic table means how these properties change among groups and periods. And again, why? Every statement there is a question is why. The first thing we have to study is valence electrons. Valence electrons in a group remains the same. In a period, valence electrons increases one by one. The second thing we studied is atomic radii. Atomic radii means the center of the nucleus to the outermost shell. That distance is known as atomic radii. Center of the nucleus to the outermost shell. How the atomic radii, that is size, how the atomic radii varies among groups and periods. In a groups, the atomic radii increases. There is no difference in the case of metal or non-metal. Generally, in the every group, atomic radii increases from top to bottom. Why? Because the number of shells increases. For example, nitrogen or phosphorus, which is the biggest atom, or which has a greater atomic radii, nitrogen or phosphorus. No doubt, nitrogen has only 2 shells, phosphorus has 3 shells. So, which has the biggest atom? Phosphorus, because it has 3 shells. And in the nitrogen group, which is the biggest atom, this element is discovered, not it is approved by the International Union IUPAC. If an element is given to study or let us look, this union, International IUPAC is International Union for Pure and Applied Chemistry. This organization is approved. We can study properties of elements. So to this we can stop these elements from this one. So in the 50th group elements, which is the biggest element, this one, because it has 6 shells. So in every group, atomic radii increases from top to bottom. We can note out from how it varies from a period from left to right. The third period, first thing we have always remember is group number denotes the valence electron, period number denotes the number of shells. In the third period, all elements have 3 shells. All elements have 3 shells. What are the all elements? You name these elements later. But then how size varies? We can, on looking the third period, what changes we can see on looking the third period, we can see that the atomic number increases 1 by 1. Atomic number increases 1 by 1. Atomic number increases 1 by 1 means number of protons increases 1 by 1. Number of protons increases 1 by 1 means what? Nuclear charge increases. Therefore, though the elements of the third group have only 3 shells, the size decreases from left to right because And the increase in due to the increase in nuclear charge, it attracts or pull towards the electrons towards the center. Then we came to the metallic character. The metals are on the left side. Metallic character means tendency to lose electrons. If the tendency to lose electrons increases, metallic character increases. This directly, the metallic character and non-metallic character directly depends upon the size of the atom. Metals, only one difference is metals lose electron, non-metals accept electron. In the case of metals, from top, in a group from top to bottom, size of the atom increases. Therefore, the size of the atom increases, and likewise, the metallic character also increases. In a group from top to bottom, metallic character increases because the size increases. So, it gives electrons very easily. So, in every group, the more reactive metals on the bottom of the periodic table, because they are very big size, atomic size is very big, it easily gives electron. In every group, less reactive metals on the top. Why? They are at a small size of the atom is very small, it has a least tendency to lose electrons. This is the same as electropositivity. In electropositivity in a group increases from top to bottom. Electropositivity means tendency to lose electron. If the size increases, the tendency to lose electron also increases, because if the size increases, the attraction towards the outermost electron is decreasing. So it easily loses electron. Then the other thing, the non-metallic character. Non-metallic character means tendency to accept electrons. It also directly depends upon size electron. Small atoms easily attract electrons. Biggest atoms tends to attract electrons is very good. So in the case of fluorine, it attracts electrons more easily towards the center. It is more reactive as it is this way. So you can have a look at the periodic table. Then you study all this. First you ask yourself some questions about what is it? This is periodic table. What is it? It is a scientific arrangement. There are, you can see so many columns and vertical columns and horizontal columns. Then you ask yourself so many questions and try to answer by yourself. In the elements are scientifically arranged, or it is arranged in increasing order of their atomic number. Then you ask yourself how many vertical columns here you count and arrange on the number of vertical columns. They are called groups. Then how many horizontal columns? You can see that they are confused between horizontal columns and vertical columns. Whenever you study horizontal columns, you look only these columns, never this. So there are 7 vertical columns. These are the periods. Then what does this group number indicate? What does the period number indicates? Or also in every group, those elements which have similar properties came under each group. These are the same properties. These are the same properties. They are also called a special name. First two group elements are called alkali metals. The second group elements are called alkaline earth metals. Third group A are called boron family, carbon family, nitrogen family, oxygen family, hydrogen family, and zero group elements or inert gases. Then we study the properties. So you never tries to try to study the properties learned by heart. You look and understand, write the electronic configuration first. Then the electronic configuration is directly related to the position in the periodic table. For example, the case of aluminium, atomic number 283. Atomic number 283, electronic configuration K2L8M3. 283. Then you can came to a conclusion it has 3 shells. 3 shells means it came to the shell number denote the period number, or period number denote the shell number. It has 3 shells, it belongs to the period. It has 3 electrons in the outermost shell, so it belongs to the 13th group or the 13th group. Then we can get to the conclusion that by on seeing the position in the periodic table, we came to a conclusion whether the element is a metal or a non-metal. If it is on the left side, it's metal. If it is right side on the metal. There is the clear-cut line between metal and non-metal. This zigzag step is known as there occurs the non-metalloids. In the left side there are metals and the right side there are metals. Then came to the different properties. Less electropositive nature, electronegative nature, size of the atom, valency, electrons, how these are varying among periods and groups. So we can come to a conclusion. You read the passage, then looking upon the periodic table, you came to study properties. Depending upon the position of the elements periodic table, you can predict the properties of almost all this. You need no need to learn this property by heart. When you by trial and error, you can remember the names of the elements as well as predict the properties of the elements. Today we can wind up this class today. We can see it in this class. Okay, thank you all.